Hey guys, we going through GCSE Maths Revision about formula rearrangements, formula substitutions, and we on problem 3 because that's the revision. So make sure you watch all the previous videos dedicated to problem 1 and problem 2. So right now we on problem 3. And here we go, we have the sphere. So pause the video, try to do by your own, then compare the answers. Alright. So we've got a sphere, and I just remind you, if we have a spherical body, so that means that one, okay, that's your actually sphere. So make sure you remember how to calculate the volume of that. So in this case, we're going to set up, let's set up the radius. That's going to be the radius. Let's take R. How to calculate the volume and surface area. So if we're talking about the volume of the sphere, the volume is given by 4/3 pi r cube. Okay, make sure you know this. And about the area, surface area, we're given by the formula. So red is pretty, kind of blurry. So cute. So what about the area of the surface? So that's gonna be 4 pi r squared. So if you're not sure which formula to use in this case, for example, you forgot, you just probably remember, but you forgot, you mess up area with volume, how to check yourself quickly. So volume should have cubic units of measurements, so meters cube. If your radius measured in meters, let's say your radius is in meters, so for the volume here you raise up power 3, so that's why you'll get meters cube. And you remember that volume actually is measured in meters cube, so that's cubic units. So that's why you never mess up the formula, okay? And what about you might mess up with 2 pi r, that's its circumference. No way, you tell me that if you use the method of units, you never be failed there, okay? So r squared is going to be meter squared, that's normally for the area. And let's say circumference length, just for for fun there. So 2 pi r. In this case, length, because circumference is basically perimeter, right, of the enclosed shape of the contour. In this case, contour is just circular curve, and it should have normal units of length, meters, centimeters, no matter. So that's why you have 2 pi r, radius is measured in meters, so hence you've got also length measured in meters. That's all correct. You see how powerful tool when using method of units. You can always check yourself in terms of the formula. So that's why this topic is really significant in maths, okay? Find the total surface area of the sphere of the radius. All right, so use simply that formula. So I mark them 1, 2, and 3. So 3 is less likely you're going to use. So in this case, surface area, make sure you use the formula 2. According to the formula 2, you'll get surface area, radius in meters, so your area is going to be meters squared, definitely. You'll use 4 pi, and here r squared means 12.5 squared, and now you have meters squared as well. That's good. You take in calculator, make sure you use your pi button. That will give you a precise value instead of just using 3.40, yeah, because 3.40 up to 2 decimal place, while precision for pi button much more. And you raise 12.5 squared, okay? So finally what I've got 1,963 and 0.495. So if you round up, you'll get 50 meters squared. Okay, that's the area, meters squared. That's the surface area. All right, so here you need to find the radius in centimeters of a spherical ball which has a surface area of 2 meters squared. Alright, so you're again using the formula 2, and right now here on a field I'm just trying to write the formula first of all. So area is 4 pi r squared. Okay, so first rearrangements, because you need to find the radius. So radius from there. Again, we already did this. So that's your radius. Now you just simply express r squared first of all, and then taking the square root of the expression. So r squared is going to be a over 4 pi, and then you just simply taking the square root of that. So that's your formula, okay? Now what are you going to do? You need to have centimeters, that's units for radius. However, surface area is in meters. So instead of like rushing ahead and trying to convert 2 meters squared in centimeters, stop, hold on. Find the radius normally in meters first. That will save you time. Okay, so radius in meters is going to be, you just plug in the formula, all the values that you have. 2 over 4 pi. Even in this case, you can cancel 2 and 4, but okay, because we have calculators, we're not going to do this. So you take in the square root of 2 over 4 pi. And in this case, you'll get 0.39. Okay, right now I'm going to use as lot digits as my calculator worked out. So 3989. Seems to me it's enough. So centimeters, how to convert? Right now you've got meters. How to convert in centimeters? You just simply need to say, okay, every single meter is 100 centimeters. So you just simply multiply by 100, and you simply transfer decimal point 2 times. So it means finally it becomes there. So final answer in centimeters is going to be 39 and 0.89. That's your answer in centimeters. So okay, yeah, I hope you can do this. Okay, so that's the final answer for Marcus Green for part B. So what about part C? Let's move on. Volume of the sphere, which surface area is 30 meters squared. Okay, here's a bit more tricky, because in this case you need to combine formula 1, which is here for the volume, and formula 2, which is here. Okay, I just erase everything that I don't need. That one to, to clarify the space. Yeah, erase the sphere, but I don't need it anymore. Okay, so that's what we've got. We've got formula 1 and formula 2. I also erase the length, circumference, so I don't need this right now. And what I'm gonna do, I just want to connect the volume with the surface area. Okay, so where's the connection point? Definitely this is the radius, because you need to connect V with A, and you're not told any single word about the radius. So that's why radius, just simply, you don't need that. So that's about simultaneous actually equations, so that, but it's without, solving, but it's about mostly rearrangements, okay? Because in this case, it's impossible to solve because you have V, A, and R. So you have 3 variables while you have just 2 equations, right? So that's why you just only can connect V and A, and that's your purpose. So basically you need to set up an equation which connects volume with the area. And that's why R is like, that's what you don't need to have in your final equation. So that's why I'm taking R squared from the formula 2 and express it. So if I write So I know that R is going to be square root of a over 4 pi. By the way, we use that here, okay? So I'll use radius as a over 4 pi. And then what I'm going to do, I'm just want to plug into the formula for the volume. So basically I plug that into the formula 1. Let's see what I have then. V is going to be 4 over 3 pi. And instead of radius cube, I'm going to have square root of a over 4 pi to the power 3. But you know, it's not convenient to work with roots, so that's why I will use index notation, and make sure you know how to work with indices. So I just simply use the power of 1 over 2, because that's the roots of power 2, so it's roots of 2, like that's the square root, so that's why the power of the root is going to be 2. But if you convert into index form, it's going to be 1 over 2, because normally according to, you know, the property of indices, square root, not square root, but nth root of a is going to be a to the power of 1 over n. So you swap that nth root power in as the fraction, so basically you flip it over and it becomes 1 over n instead. So I use this fact here. Okay, that's the radius. And now when I plug this radius into the formula 1 for the volume, where I have r cubed, I just simply write that it's 8 over 4 pi, that's the radius, and to the power 1 over 2 and to the power 3. So finally I've got 3 over 2. That's the power. So power in the power, so in this case you multiply powers, so that's where I use that property. So 8 to the power of n, in this case n is 1 over 2, and to the power of m is going to be 3, okay? So I simply use multiplication, so n times m. And when I multiply 1 over 2 by 3, I'll simply get 3 over 2, okay? That's how it works, and that's the final formula which connects volume now into with A. So make sure you can check using the units method. So what you've got volume in meter cube. It's normally the case. So what about the area? So units of, on the left hand side is meters cube. So what about units on the right hand side? Area is meter squared. So you just get rid of that. It's just simply number, for pi as well as number. So you take care about 8. So maybe it's better for you guys on the first step to write that V is proportional to basically a 3 power 3 over 2. So now you clearly see what you actually need to compare. Units of volume, meters cube, you're going to compare it with area. So area itself is measured in meters squared. But now you take a meter squared and raise to the power 3 over 2. Now you again use that index rule and index features. And now what you're going to do, you multiply in 2 by 3 over 2. So finally you'll get 3 over 2 multiplied by 2. So what will be cancelled? Obviously, that one. 2 here and 2 here. And finally you'll be left with m to the power 3 on the right hand side. So now you've got the right units there. If you're checked and you see that, okay, units are different, like meters cube is going to be equal like square root of meters, for example. Obviously you did incorrectly. So go back and one more time try to see what you missed, okay? So this is the way, and now we just simply need to calculate. So we need to use that. This is the formula. Right now what I'm going to do, I'm just want to shift that a little bit. Okay, I hope I can do this. Yeah, I can squeeze that. That's cool. That's how you can check it. And now we just simply calculate volume using that formula. So we've got a formula. Guys, make sure you have the same. Okay, and we use that in order to calculate volume. So volume is going to be, we've got area 30 meters squared. So we use the formula. 4 over 3 pi, because we have calculator, we don't care about 4 pi, so we just calculate one single action. So multiplied by a, which is 30 over 4 pi, and to the power 3 over 2. I hope every single calculator should have this like fractional power. And let's take the result. So, sorry, I need to shift this again. Yeah. Okay, yeah, that's how you can check the units, all right? So now what I'm gonna do, I'm gonna use that and just simply keep my calculations going. So 4 pi times brackets, so 30 over 4 pi, okay, then to the power 1.5, that's 3 over 2, but you can write the power as a fractional, and then everything you divide it by 3. Okay, so everything you need to divide by 3. I hope I did it correctly. If you have another value, just share in comments and we just reconcile. I've got 15.45 to 2 decimal place, now meters cube. Okay, so that's my result. Make sure you have the same. If not, just share in comments what exactly have, and we just maybe discuss why is that so. I'll definitely give you feedback in the comments. And don't forget, guys, to also ask me about if you're a GCSE student, so try to drop the comments which topic you would like to see in my videos. If everything is going well, like just we go on schedule, I'll be doing according to my wait list. Okay, that was Daniel Dallas. Thank you, guys. Don't forget to subscribe if you're new here. Join our GCSE routes and you'll be tuned up definitely. Okay, make sure you watch all the previous video in order to be updated right now. Thank you and peace out.